Okay, let's take a look at this derivative. We're looking to find the derivative of f of t equals e to the at times sine of bt. So when we look at this function, we want to try to decide what kind of rules we're going to need to take the derivative. I notice a couple of things. One, I see a product going on. This is e to the at times sine of bt. That tells me that I'm going to be using product rule in order to take this derivative. But in addition to that, I notice that I don't just have the variable up in the exponent of my exponential. T is my variable because this is f of t. So I have an entire function sitting up here, that function being a times t. Also, inside my trig function, I don't just have t, I have bt. So both of those derivatives are actually going to involve chain rule as well. So let's start by writing out my product rule. So the derivative with respect to t, f prime of t, also known as df dt, I'm going to do the derivative of the first function first. So the derivative of e to the at is e to the at, but times the derivative of at. So for the moment, I'm going to write that as at prime, meaning I'm going to take the derivative of this in just a bit. Now that's going to be, by product rule, that's the derivative of the first function. I need to multiply that times the second function. So that's times the sine of bt, as is. And then plus, I need the first function as is, so that's e to the at, times the derivative of the second function. Well, the derivative of sine bt is going to be cosine bt, do not touch that inside function, times the derivative of the inside function, so times bt prime, meaning I'm about to take the derivative of that. So once I've got the product rule written out, really all I have left to do is take the derivative of at and take the derivative of bt. Keep in mind that our independent variable is t. So when you go to take the derivative of a times t, it would be like taking the derivative of, let's say, 6t or 10t. A acts as a constant. So when you take the derivative of a constant times the linear, you just get the constant itself. So the derivative of at is a. So I'm going to write a e to the at sine of bt. And then for my second term, I'll have e to the at times cosine of bt. I haven't done anything with that yet. And then the derivative of bt with respect to t is again that constant b, which I'll go ahead and choose to write out front here so I don't get confused. And that's the derivative.